Okay, so today we're going to be doing our math exam 3 review. We're going to be doing it on ANOVA. So on ANOVA, on our review sheet, we're going to be using this to help us out with our problem. So the question reads, a manager would like to determine if there are significant differences in the mean sales among 4 stores. The following table shows the sales in thousands of dollars tracked over 5 days. Test her claim using the significance of 5%. So the keyword here that helps us identify that this is ANOVA is going to be mean right here. Mean sales. That's going to help us identify that this is ANOVA, and it's going to help us with our null hypothesis. So first we want to see how many groups we have. So we have 1, 2, 3, 4. And we can label it to help us on the side. Group 1, Group 2, Group 3, and Group 4. So we have to be careful with this problem because we don't want to identify day 1, day 2, day 3, day 4, day 5 as our variables. We want to identify, we want to be careful, and this is what we're identifying. We're identifying the mean sales in different stores. So first what we do for letter A, we're going to identify the null and alternative hypothesis. So to start off, for our null hypothesis, remember we're talking about mean, so we're using mu. So mu1 equals mu2 equals mu3 equals mu4. Again, we want to be careful and not put 5 because we're not talking about days, we're talking about stores. And then the alternative is going to be that at least one mean sales is either not equal or different. Keyword right here, we're talking about mean sales. Okay, letter B, using ANOVA on your calculator, find a test statistic F and the p-value. So for our calculators, we are going to do, let me see if I can remember, second verse, nope, just kidding, stat edit. And since we have 4 groups, we're gonna basically go across. We want to make sure that we're not going straight down because we're talking about Alhambra store straight across. So that's why we got to be careful here. So really quick, I'm going to put it into my calculator. 10, 20, 20. Just make sure we have our numbers correct when we're inputting. 20, 25, 15, 20. Next, 3, 7, 25. Nope, just kidding. 5, 10, and 4. Enter. And then our last one for Downey store, 30, 25, 30, 35, and 30. So right after we get our graph here, we want to go to stat. We want to go over to test. And in order to find ANOVA, it's easier on our calculator to just, instead of going all the way down, we can go up and then we click ANOVA. So this is always going to be a right tail test. So let me see, how do we find the p-value again? Oh, okay, yeah, I remember. So we have to manually put second L1, comma, second L2, comma, second L3, comma, second L4. Since we're talking about 4, we're going to enter that, and it's going to give us basically what we need. So in this case, for our F, it's going to be, wait, I did something wrong. Okay, I did something wrong because that's not what our values are supposed to look like. Let me see if I can go back. Stat, calc. Let's see if I put my values in correctly. 10, 10, 20, 20, 20, 20, 25. Oh, I think I found what this is supposed to be 15. And 20, 3, 7, 5, 10, 4, 30, 25, 30, 35. Okay, so that's a good thing that we caught that on time. So we're gonna go to stat. I forgot. Stat.
Cooperate.
Okay. Okay. Now we're gonna do the same thing. Second L1, second L2, comma, second L3, comma, second L4. Okay, that's better. Our numbers are, we're looking at F in our calculator, 35. And we want to keep it to 3 decimal places, to 295. And then we have our p-value, which is 2.7665, so on. And then our calculator shows E -4, which means we have to move the decimal 7 times, which is basically going to be 0.00000027665. Since we have a lot of zeros right here, this basically is going to equal 0. So next, on letter C, we're going to try to make a conclusion with our alternative and our null. So our p-value is basically 0%. And we want to make sure we find the level of significance, which is going to be 5%. Is 0% less than 5%? Yes. In that case, we write that this is statistically significant. So we reject the null and support the alternative. That's how you write that. Now we're gonna move on to letter D to state our conclusion in the context of the problem.
Wait, where do we find the claim?
Okay, good question. So in order to find the claim, we have to look at alternative. So our alternative is where we find our claim. Right here, we're talking about that at least one mean sales is not equal or different. So that's going to help us rewrite our conclusion in the context of this problem. So at 5% significance level, the data support the claim that, and we look at our alternative, that at least one mean sales is not equal. And that is how you write the conclusion for this context of ANOVA review. Thank you.